this is a priori algorithm. Again, one of the simpler, one of the older, but one of the most commonly used algorithms that we have, a priori algorithm or association rule learning. Now let's try and understand, what do you mean by association rule learning? What is a priori algorithm? And then how does it work? Also, a priori algorithm is one of the smallest programs that you will find in machine learning. So what exactly is association rule learning? Let's try and understand this, please. Now, see, the best method to understand this is the market basket analysis. Now, what do you mean by a market? What do you mean by market basket analysis? See, when you go to a supermarket, if you talk of something like, say, a D-Mart or a Big Bazaar or any of these markets that we have, they have thousands and thousands of things. Now, what they do is they will go to their floor and they will divide that particular floor in different sections. So suppose you have say a section, say for say bakery products, you will have say a section say for clothes, you will have a section for something else, and so on. There will be so many different sections. But even in that particular section, what they will have to do is they will have to try and decide how to place the products. Now, why is it, or why does it matter? See, there are two things to it. One, what we find is that whenever people are buying certain things, it is at times possible that people buy certain combinations. An example of this could be a person who is out to buy a shampoo is also likely to buy, say, a conditioner. Or maybe a conditioner is something which is the most popularly picked up product whenever a shampoo is picked up. So what you will find in these stores is that whenever you go to a section where you have, say, shampoos, where you have shampoos, you will also find conditioners placed next to it. Now, the reason is it will help in two given ways. One, any customer who's out to buy, say shampoo, is most likely to buy a conditioner as well. So the person finds the product there itself. So that makes the shopping faster and easier for the customer, and the customer would be out of the store at the earliest. And second is it also pushes sales, right? So what the companies will try and do is whatever are the transactions that are happening in their place, they will analyze all those transactions. They will try and identify the products which are usually bought together, and then they'll try and place them together. Now, this is exactly what a priori algorithm is going to do for you. Whatever other set of transactions you have, you feed that transactions to this algorithm. This algorithm will check the transactions. It will try and find out the relation between the commodities picked up, and it will help you understand what commodities are most likely to be picked together, so that you can also decide how they are to be placed in the store. Now, in the physical store, we want these products to be placed in the racks or the shelves nearby. This happens on the online store as well. See, today when you go out and shop, say on say Amazon or maybe say Flipkart, what you will find is if you're buying something, if you're buying something, then they'll say that okay, um, uh, people who bought this have also bought this, or the people who bought this generally buy this. They'll give you predictions. Now, how are they doing it? Now, on daily basis, there are so many transactions happening on Amazon. What Amazon would do is Amazon will analyze all these transactions and try and find a correlation between the products, and then they'll recommend you that. Now, suppose it so happens, suppose say I go and say buy a mobile phone, or maybe I've just added a mobile phone to the cart. Immediately it will show me that people who bought this also bought this. So it will show me a good headphone, it will show me say the scratch guard, or it will show me say the mobile phone cover, and so on. It will show me all these things, right? So that is nothing but the result of market basket analysis or the association rule. It will just try to find the correlation between the products, and then it will analyze. It will rarely happen. It can, I cannot deny, but you will not see that you've bought a mobile phone and then in the recommendations it is showing you an Apple. Now there is hardly any probability of someone buying an Apple along with phone. See, you can't say no. I can go to Amazon and order Apple and sorry, when I say Apple, I mean Apple fruit, not the phone. It could be any phone, and say I'm buying say a mango. It is possible that I can buy a phone and a mango at the same time. But what is the probability of that happening? Nowhere in the world you walk into a store, you'll find a phone and a mango kept nearby, because it doesn't go with the association rule. See, one example that I could think of straight away was a shampoo and a conditioner. Maybe say a phone and say the mobile phone cover. These are the things. Can you quickly give me in the chat window what are the products which you would generally buy together? Generally, when you go out to buy one, you'll pick up the other as well. Any combination that you guys can think of. Toothbrush and toothpaste. Okay. Yes, that could be one. Coffee and biscuits. Yes. Books and stationery. Yes, that could be one. Okay. Now let us try and understand this with a simple example. See, there are four parameters on which this entire concept works. So what we'll do is we will first look at this little example. With this example, we'll understand what are those four terms. And once you've understand all those, once you all understand those four terms, once you all understand those four terms, you'll be easily able to implement it. Again, when I'm going to implement this particular concept, again, I'm literally going to do it in two lines, but then you need to understand the terms that we will be working with and what those two lines would be doing in the background. Now, suppose I have this information about, say, 5 transactions that have happened where people have picked up, say, milk, sugar, and coffee. And then I now need to understand, or I need to find, or I need to apply the association rule. And I need to figure out what combinations will work for me. Now, in the first transaction, the person actually came to pick up milk, but also picked up sugar and coffee. Second time also it happened, the person came to pick up milk and sugar and coffee was also picked up. There was a person who picked up only milk and sugar, and there was one fellow who picked up only sugar. Suppose this is the set of transactions that I have. Now, the four terms on which the whole of the concepts the whole of the concept works on is this. Guys, observe this. There are four important parameters that we work with. The first one is called as support, or in other terms, you can say, which over here we will be looking at the popularity of the product. See, guys, please understand this. I'm going to look at this example like this. If somebody wants to pick up, if somebody has come in to pick milk, then what is the probability that the person will also pick up sugar? The person will also pick up coffee. So it is the popularity of the product that will drive the sales for the other one. See, if somebody goes to buy a mobile phone, that person might think of buying, say the mobile phone cover. I don't think it happens frequently that somebody actually wanted to buy a mobile phone cover and then the fellow sees mobile phone and buys a mobile phone just because the person was in to buy a mobile phone cover. So you need to understand the popularity of a product will drive the sales or will drive the picking up of the other products. So there are certain terms which you need to understand. The first term is support. X is the product. So if I want to get the support of X, what are the things that we are looking at? What this means is we will look at the number of transactions in which the product appears divided by the total number of transactions. So basically what we are trying to do is we are trying to figure out the popularity of a particular product. Now suppose if I want to get the support for coffee. So over here, what I'll do is the total number of transactions that I have are 5, out of which coffee appears 3 times. So the support of coffee or popularity of coffee is 3 divided by 5, which is 0.6. Now, guys, over here, 0.6 is effectively 60%, which is pretty high, right? But understand, we'll keep getting very high numbers because there are only 5 transactions that we are looking at and just 3 products. Now, what this means is of all the transactions that have happened, 60% of times coffee was picked up. So it is a pretty popular commodity. Now, whenever we are designing our model, we need to decide on the threshold. So see, how do I say that this product is popular? See, 60% is very high because I don't think any product for that matter, if you go to a D-Mart or maybe a big bazaar, say if you look at the transaction, suppose there are say 500 transactions that have happened through the day. Out of 500 transactions, I don't think there's a product which has been picked up say 300 times. Maybe in cases in say times like today, maybe something like a sanitizer gets picked up say every time. Now this has happened with me every time when I go to the store. If I see a small sanitizer bottle, I'll just end up picking up. Honestly, I don't need it, but I just end up picking it up. I'll keep it either in the car or in the room. Literally everywhere you can find sanitizers these times. But then again, getting a popularity of about 60% is very difficult for a particular product, right? Unless it is little too popular. So generally, if we get a 20% or a 25% popularity, that is good enough. So whatever it is, you have to decide on the threshold that, okay, if I'm getting 25% and above, I'm happy with the popularity of the product. So you need to decide on the threshold. Suppose if we are taking, say, threshold of 0.5, that means 50%. So what I mean is that in the transaction, if the transaction appears, the product appears at least 50% of times, then for me the product is of interest, it is popular for me, else it is not popular. So that is support. Once you get the support, then you will look at the confidence. Now what do you mean by confidence? Confidence of X implies Y. What this means is, what is the popularity of Y, or what is the probability of Y getting picked up whenever X is picked up. That means, suppose if I say milk and coffee, when I say confidence of milk and coffee, what this means is, what is the possibility of coffee getting picked up by a person who had actually come in to just pick up milk. So milk is the more popular product. Somebody who walks in to pick up milk will end up picking up say coffee. So that is the confidence that we are looking at. If I find this value to be high, if I'm convinced that most people who walk in to buy milk will also end up buying coffee, I'll place milk and coffee on the shelves next to each other in my store. Now how do I do that? I'll just check this. This is support of milk and coffee. Sorry, this is support of X union Y divided by support of X. All these calculations will happen in the background. You'll get the values directly again. So support of milk and coffee divided by support of milk. How do I get support of milk and coffee? See over here, of the 5 transactions, milk and coffee were picked up thrice. So support of milk and coffee combination is 3 out of 5. And what is the support of milk? Out of 5 transactions, milk has appeared 4 times. So this is 4.5 times. So, sorry, 4 divided by 5. So when I get this, it gets 0.75. Now this can be cross-checked with this as well, that if you see 4 times milk has got picked up, and out of which 3 times coffee was also picked up. So 75% chances there that any person who is walking in to buy milk will also buy coffee, or coffee will get picked up. So that is 75% is a very high ratio. Practically you don't get that, but again I repeat, because we are working with very small data set and we have just 2 or 3 products, we are getting such high values. Practically it doesn't work with such high values. Now, so over here I can always pick up a popular product, and based on that you will pick up the other products. See, this applies to any product, any commodity, for that commodity for that matter. Everybody knows that in our store this is the most popular product. Then what they'll do is they will try to promote other products using this popular product as a reference. Now if I talk of Parley Company has existed forever. There are n number of products that Parley Company produces, manufactures, but the most popular product in India from Parley Company has always been the Parley G biscuit. For decades now, it has been one of the highest selling biscuits that we have had in India. I don't know, I guess even today, if you look at the sales of biscuits, I think Parle G would be right up there at the top, right? Guys, can you just give me a tentative number for how many years have you eaten Parle G biscuits? There are 1,000 other biscuits that come in. For how many years have you all eaten Parle G? 20 years. Okay. 20 plus years. Everybody says 20 years. Okay. Acha guys, can you give me the names of the other biscuits manufactured by Parle? No Google. Dark Fantasy, yes, pretty popular. Hide and Seek, Tiger. Okay. No, 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 no. Britannia is a different company altogether. Rafi, no. Good Day. I don't think Good Day is a Parle product. Is it so? I'm not sure. I'm not sure. Monaco. Yes. Yes. Parley Crackjack is also pretty popular. Right? Okay. Anyways, so over here, see, Parle G, everybody knows, but moment I said some other biscuit, I'm sure you would be required to think a bit. So what the company would try and do is, company will try to leverage the popularity of Parle, and then they will try to push their other products as well. So that is where something like a confidence and all will come into picture. So suppose assuming that in my data set, say milk is the most popular product. So milk is the driving product based on which I will be trying to push the other product. So I can get this confidence. But guys, understand there is a problem with this particular term confidence, or the way this confidence is calculated. Now observe this over here. I'm telling you that the probability of coffee getting picked up whenever milk is bought is 75%. So this is actually, if at all it is the case, now it is simply awesome for the company, because 75% times whenever milk is bought, coffee is bought, right? But guys, understand, it is possible that I had walked into buy milk and I picked up coffee as well. Milk is the more popular product. But then if milk and coffee are appearing together, it is possible that some person had actually walked in to buy coffee and ended up buying milk also. See, both milk and coffee are appearing in the same transaction. True. But it's not always, or how do you conclude that coffee was bought just because milk was bought? It could have been that the milk was bought when the coffee was bought. Now, guys, suppose I went to pick up Parle G. I bought Crackjack. Most people will assume that yes, because this fellow was buying Parle G and saw Crackjack, the person picked up Crackjack. But it could have also happened that Crackjack was also a popular product, but maybe not as popular as a Parle G. I had come to pick up Crackjack. I ended up picking up Parle G. Na? So over here, when I say the purchase of milk is pushing the purchase of coffee, the reverse implication is not taken into account. What about the purchase of coffee pushing the purchase of milk? So confidence you can always calculate. Now, in terms of say Parle-G and Crackjack example, I'm happy with the confidence because I have decades of data set available with me, which tells me that Parle-G is the most picked up biscuit. So in all probabilities, anybody who is coming to pick up Parle product will pick up Parle-G, and anything else, say a Crackjack gets picked up, the Crackjack got picked up because the person was there, to pick up Parle-G. That is what I would want to believe, and then I'll go with the confidence. But then if I talk of say two other products which might not be say the correlation is not very obvious. Suppose there is this biscuit say called Dark Fantasy, and there is this biscuit called say Nice Time, right? Both these products are say popular products, but not very popular. Like Parle G wins hands down. But suppose if Dark Fantasy and say Nice Time were bought together, I assume that person had walked into buy Dark Fantasy, also bought Nice Time, but it is equally possible that a person who had bought Nice Time would have bought Dark Fantasy as well. I don't have that dispute with Parle G. I'm happy with the confidence. But when you talk of Dark Fantasy and Nice Time, I'm not sure. If you tell me the person who bought Dark Fantasy also bought Nice Time and say there is 70% of chance of this, I'm not sure of this confidence value, because I know Dark Fantasy, yes, is a good, maybe a popular product, but I know that it is not as popular a product that so many people will actually pick up something because they had walked in to buy Dark Fantasy. So to overcome this limitation of not considering reverse implication, we have one more term which is called as lift. So you need to decide whether confidence is good enough for you or whether you will go with lift. So if at all I was working with the Parle G Crackjack example, I'll stick to confidence. But if I'm working with the Dark Fantasy Nice Time example, I will go to lift. Now, how do I calculate lift? So lift actually takes two things into account. If milk is the driving product, then what is the probability of coffee being picked up because the person was wanting to pick up milk? Second is, what is the probability of the milk being picked up when the person was wanting to pick up coffee? Both have to be taken into account. So the formula for X driving Y is support of X union Y divided by support of X and support of Y. So the probability of coffee getting picked up when the person had walked in to pick up milk is support of milk comma coffee divided by support of milk multiplied by support of coffee. So when I substitute this over here, I get it as 1.25. I'll get these values. Now guys, this value that I get for lift, this value would be 1, less than 1, or greater than 1. If I get the value 1, that means there is no association between the products. Now suppose it so happened that maybe one person today walked in, that person bought say milk, and that person say bought apple, right, from the supermarket. So my transaction say milk, says milk and apple. Now if I have some particular data set, and if I try to analyze say milk and apple, say 1,000 transactions have happened today, but there are only 5 transactions where people have picked up milk and apple together, then what I'll find is I'll get the value 1. That means there is no correlation. There is absolutely not data enough which gives me some kind of a correlation between milk and apple, so that cannot be considered. If I get the value as 1, which is the case in our example, what this means is that the probability of coffee getting picked up whenever the person has come in to buy milk is high. That is what it will mean. So I will say if I get the value more than 1, yes, these two products are correlated and the chances of them getting picked up are higher. So let's put them close to each other on the shelf if it's a physical shop, or let's add it to the recommendations if it is say an online store. That is what we'll do. If the value is 1, what this means is that yes, there are evidences that sometimes coffee is bought whenever the milk is bought, but it is not satisfactory that every time somebody is coming in to buy milk would want to buy coffee. So milk cannot drive the sales of coffee. So over there, I may decide to put them together, or I may not decide to put them together. I need the value over 1 to be sure, okay, that there is a strong correlation between the two products. So let me just keep these two products together. So that is what is this value. In our case, because there are 5 values and 3 times milk and coffee are getting picked up together, 60% of times it is getting picked up together, which is again a very high number. That is why straight away I've got a value of more than 1 over here. So that is how I'll understand that milk and coffee would be picked up together. Finally, you have something called as conviction. Now, conviction is, see, I'm telling you that the sale of coffee is driven by the sale of milk. That means most people actually walk in to buy milk and also end up buying coffee. Now I need to understand what is the conviction that I have that that coffee will get picked up, say whenever milk is sold. What is the belief value that I have, or you can say how strong is the belief that yes, coffee will be picked up whenever milk is being picked up by some person in the supermarket. So the formula for conviction is given as 1 minus support of y. If this is milk and this is coffee, so this will be 1 minus support of coffee divided by 1 minus confidence of milk driving coffee. So this is milk driving coffee. So over here 1 minus this, and then I calculate this and I get 0.15. So over here, if the value of this conviction was high, I will see that yes, the chances of coffee getting picked up whenever milk is being picked up is higher. If the value is low, we will say that no, milk cannot drive the sales of coffee. So what we'll do is we will keep analyzing this, and we'll keep generating recommendations. See, sites like say Snapdeal or Flipkart or Amazon or eBay, they keep doing this at all times. Literally lakhs of transactions happen on say Amazon literally every day. They will analyze it and they'll see what are the products that are being picked up together, and then they'll keep adding them to the recommended systems. And not just that, now the limit is that okay, you might have bought say suppose if I take the example of milk and coffee, they find that coffee is pretty popular whenever say milk is picked up. What they'll do is, if you've picked up milk and if you've not picked up coffee, and they know that these are the products which will be picked up, which are likely to be picked up together, they'll just keep showing you recommendations. They'll keep showing you ads. Even if you've moved out of Amazon, you'll keep seeing ads for the products which are correlated. So that is how it happens over here. Forget this, forget buying. Even if you are just scanning, so many of us just go for say window shopping on these apps like Amazon and all. They keep track of that as well. What is it that you saw, and based on that they'll keep showing you the ads at all times. Everyone does it. Go to Make My Trip, just search for flights between say Mumbai and Goa. You haven't booked any flight, come back, 100 times you will see ads for Mumbai Goa flights. Now that is the level to which they are tracking today. So a priori algorithm, though a very simple thing, but very popular, very important for the marketplaces. So the four terms are support, confidence, lift, and conviction. With the example, we've just seen the formula, but honestly, if you don't know these formula, absolutely it doesn't make a difference. I'll go to the program, and in the program, you will see that the system will apply these formulae on its own. That is how it is going to work. Now, for this, I'm going to be working with a data set called store underscore data one. I'll just show you this data set and I'll give you the code as well. Very small program, but over here, see what happens is, no, not this data set. This is an incorrect data set. Uh, just a sec. A priori algorithm. Mhm. Just a sec, guys. I'll just show you the data set that I'm working with. Yes. Okay, see this. Now over here, we have a data set which has about 16 rows, right? See, my actual data set is 7,000 rows, but what happens is if we try to run with that, it will try each and every combination. So it takes a lot of time. So I've just gone with a smaller data set. I have 16 rows over here, which gives me the combination of different things that the people have got bought together. And then there is this first person who's bought all these things together. So what we'll do is, I think we have about some 20 columns over here, and we have about 16 rows. So we will see how to apply a priori algorithm to this particular data set and how does this work. Code would be one of the smallest, one of the simplest to implement. Again, if you've understood the concept, if you've understood the purpose, next time you should be able to know, okay, I need to carry out this kind of classification from the store. So I need a priori algorithm. The codes would remain exactly the same. Just feed it whatever the data that you have, and then you'll get your results. Now over here, what I'm going to be doing is, whatever is the data set, I want that data set to be processed, and then I want to see the value of the confidence and lift, or even if you want the conviction, I want those values to be displayed. Now observe this. I'll just show you this program first. When I run this, see over here, see there are too many steps. It'll be able to display only whatever the buffer can hold, but there are a lot many more entries for every combination, right? For every combination, say burgers and turkey, or maybe for eggs and burgers, what is the support, what is the confidence, and what is the lift? So that is what is calculated over here. Now observe this. How is this going to happen? If you see this, as always, what I've done is I first opened this particular data set. It's a CSV file, and then I'll display the first 5 rows. Now, what I need to do is I need to get all possible combinations. So suppose now we had, say, milk, sugar, and coffee. So I want milk and sugar, milk and coffee, sugar and coffee, milk, sugar, and coffee, and so on, all possible combinations. So what we do is, in the data set that I have 16 rows and I have 8 columns, right? So what we'll do is, we've written a loop over here, which is going to get me all the combinations out here, and all these values will get added to this list called records. So actually there will be just too many values in this record. So over here, you can just get all possible combinations in this list called record. Now suppose if you go to a database which has 1,000 entries, 1,000 rows, then this value from 16 will change to 1,000. If you have, say, 20 columns, then this will become 20. But then you can imagine the number of permutations and combinations that are possible, and practically that is done, make no mistake about it. But for us, because it will take too much of time for processing, we've reduced this, because this actual store data that I have, it has about 7,000 rows and 20 columns. So it is about 1,40,000 values, and then you can imagine the number of combinations. So it takes a lot of time for executing that program, and we'll not be able to see the output because the buffer in the console will not be able to hold those many values. In fact, it cannot hold even for this. Now these are the 2 lines. All of your a priori algorithm will get implemented over here. What I do is I call this function, but before I use this, But before I use this, where's it? I need to import this. So on your systems, if you are running your Python system, it might just give you an error. So you'll be required to install this particular library, right? So for Apriori algorithm, Apriori is the module which you need to install. The command is pip install this one. Now observe this. When you go over here, I'm passing records. What is records? Records is basically a list which has all possible combination of the products that have been bought. Minimum support that I'm looking at is say 4.5%. That is the minimum support that I'm looking at. Minimum confidence that I want is 0.2. That means 20%. Minimum lift is 3 and minimum length is 2. So I want minimum length as 2. So it is milk and coffee, milk and sugar, and then later on milk, sugar and coffee, and so on. So you'll just pass this data. All the calculations that we've spoken about, everything will happen in the background with this one line. Whatever formulae and all, everything that you saw, that would be applied to all possible combinations in this one line. And what this will do is, this statement will return the address where it has stored all the result. So actually speaking, your a priori function will actually do whatever is needed, and you return the result which gets stored in this particular variable. Now using this variable, I will go to that address where I have entire data, and from there I'm going to display. So what I'll do is, I've got to that particular location, and then I've got all the results. So I have all the results in this particular list called association results. Now from over here, I will have for item in association result. Each item over here refers to a row. The first position would be for the first item that is picked up. For the next position, index 1, you will have the item which is picked up along with that. And because it's a multi-dimensional array that we create, like what we do in NumPy, confidence is always stored at these indexes and lift is always stored at these indexes. You'll never be required to change this. So again, from line number 12 to line number 30, you'll never be required to change this irrespective of the system that you're designing. If you want you to change the support and the confidence and something, you can, but the standard values that work most of the times, you will find it over here. Right now, when I run this, it will give me all possible combinations. See, practically what we do is, over here we've just displayed and left. Otherwise, what I would have done is, whatever data that I'm getting, item 0, item 1, and all this, I will push everything into an Excel sheet. And then what I do is, in that Excel sheet, I'll just apply some kind of sorting, and I'll pick up only those combinations which actually support, or which actually satisfy all the criteria that we are interested in. So that is how this system is going to work. So it appears to be a very simple, it is a very simple algorithm, honestly, but practically it is required at all times whenever you have any kind of market basket analysis to be done. Is this understood, please? See, Fawaz, I guess this answers your question. I had imported something, but I have not used that in this particular function. That is why it is giving me those errors. It's not an error, it's just a warning. It is just highlighting that you've not used it. But if I go and if I try to put everything in the Excel sheet and all, which I've taken out of this code, so for that I'll need NumPy and stuff. If you want to draw some graphs and stuff, then you can do it using Matplotlib. But then you've got to be a little careful with the data sets that you're working with. Oh, also, guys, I think I'd shown this last time, but most of you forgotten where to find the data. I've shown you this link. If you go here to khatibclasses.com, if you go to downloads, you have a folder called Python datasets. If you click on this, you will find all the data sets that I'm working with. In fact, it has a lot of extra data sets also. See, today we spoke about this Titanic data set. We were using that. Then I think we use something else as well. Yes, for recipe one, for SVM, that cupcake thing that we saw, that is what we have over here. If you go to the next page, you will find this one, store a priori, the one which I discussed just now. So you just download and keep all these data sets. We will be using 14 15 of those, but all the data sets that I work with all my courses, with Python, with machine learning, and with AI, we keep updating over here. So this is as far as the data sets are concerned. Now over here also, this is data sets, all Excel sheets, CSV files, and there might be an odd zip files. Like for hypothesis testing that we'll be doing in one of the later sessions, you will find that hypothesis testing, I need I need multiple data sets. So I've uploaded a zip file for that. It has 4 data sets over there. Now all your PDF files would be updated over here, conclave, everything. The password is CON123, and then when you log in, you will find all these PDF files session wise. They'll get updated over here. I've updated logistic, I've updated support. I'm still to update Apriori. So that is what we'll do. Every session, whatever we are doing, things will get updated over here. So by the time we finish, you'll have about 14, 15 PDF files over here, and you'll have all the data sets are already up there. So session wise, I'll keep updating the PDFs over here. So every time anything is needed, you can always download from these 2 links. I guess that is clear for everyone, right? So this is something which we should not be required to repeat. You'll find everything on those 2 links. So before or after every session, you can just check that particular link. You will be able to find whatever is needed. Like for the next session, I'll be uploading KNN algorithm, K-means algorithm, and maybe one more algorithm. The way we've gone about taking 3 algorithms, we'll try and do something similar. Logistic regression was a little heavier one. Generally what I do is, if I have a heavy algorithm coming in, with that I'll always club the lighter ones. If you see, there's nothing much conceptually if you talk of a priori algorithm or even the SVM one. Next time also, K-means and KNN, they will take a little bit of time. We'll club it up with one of the simpler algorithm. So that is what we will try and do. Guys, the key here is just make